A very good morning, ladies and gentlemen, and you're very welcome to our 100th episode of the Signpost webinar series. We hope you are keeping safe and well wherever you're joining us from today. What began as an initial 8 webinars as our response to the COVID-19 pandemic has turned into a weekly staple for us all. And so after a pandemic, multiple storms, and now sadly a war in Europe, it's still great for us all to be meeting on a Friday morning to discuss the challenges and opportunities around sustainability. And I want to take this opportunity to say a big thank you to all our contributors over the past number of years, our fantastic team, who are our series producer, Andy Boland, technical support from Yvonne Maher, our connected team, Michelle Lavelle and Nuala Cully, and of course, Pat Murphy for supporting the overall series and for assisting with questions every Friday morning. And of course, we want to say a huge thank you to you, the audience, for your continued support and insightful questions. We really have enjoyed having your company every Friday morning over the last number of years. I also want to acknowledge our partners, Dairy Sustainability Ireland, the National Rural Network and Food Drink Ireland SkillNet for their support over the last number of years. So today we're going to take a look at carbon sequestration and its impact on the impact of the water table on peat soils. And we're delighted to be joined by our own Professor Gary Lanigan, who's Principal Research Officer with Teagasc and world expert in greenhouse gas emissions from agriculture and carbon sequestration. Good morning, Gary. You're very welcome to our 100th episode.
Morning, Mark, and thanks for inviting me.
And Gary, you were one of our first speakers on the series. It's hard to believe.
That's right, yeah.
That's 2 years later. A lot of water has gone under the bridge since then. And I know in the intervening period, there's been a climate bill and so forth. So you're going to talk to us a little bit about that today.
Yeah, so what I'll do is I'll probably set the scene, go through a little bit on the climate bill, and then talk about carbon sequestration, and then talk about peat soils.
Great. Pat, it's hard to believe 100 episodes almost under the belt.
Yeah.
Where has the time gone?
It's flown. You'd never have believed that it would stretch this far. And I suppose one of the things reflecting back on it that's been really important for us is when we see the questions coming in and the diversity of the audience we have. It keeps us, I suppose, well grounded and seeing a very broad sphere of opinion coming through in the questions, and it keeps us reminded that different people see environmental issues from different angles, and it keeps us, I think, well in tune with a lot of the different angles that people are coming to us from, and that kind of diversity in the audience have been really great.
Absolutely, yeah. And I think your people's suggestions for talks and speakers over the years have been really helpful as well. So, and we do encourage everyone to continue to send through those suggestions of areas that you'd like to hear more about. So I'm conscious time is ticking on. We're here to discuss a very important topic this morning. So Gary, I might ask you to share your screen with us and just take the opportunity to remind everybody, if you do have a question that you'd like us to put to Gary at the end of his presentation, please use the Q&A tab at the bottom of your screen. Today's session is being recorded and will be available on the Teagasc website, along with the presentation and a podcast version of the talk as well. So Gary, looking forward to your talk, and we'll chat to you afterwards.
Okay, thanks a lot, Mark. So I suppose, first of all, I'll talk really through the challenges that we face over the next number of years. Okay, so the main challenge that we have from a climate point of view is that the National Climate Action Bill has set Ireland quite ambitious targets to reduce greenhouse gas emissions from the whole of society. And national greenhouse gas emissions must be reduced by 51% by 2030 relative to where we were in 2018. Okay, so 2018 is the benchmark year that the reductions are being set in comparison to. And I suppose agriculture is, agriculture is a large tranche of our emissions. So last year, agriculture was 34% of national greenhouse gas emissions. This year, agriculture will be 37% of national emissions. And really, again, we're unusual as a country in that we have such a large proportion of our emissions that are sourced within agriculture. Well, but I suppose the bit that doesn't get a whole lot of headlines is that we also, as well as having a category called agriculture, we have another category called land use change and forestry, or LULUCF for short. And LULUCF is also a net source of emissions, which again, Ireland is highly unusual. Most European countries would have generally very large forestry sinks, and their LULUCF categories would generally tend to be removing more CO2 from the atmosphere than it's actually emitting. We're a little bit different, and I'll go into why in a minute. But if you actually total agriculture, forestry, and other land use into a single category, that whole AFLU category, which is agriculture plus the land use change sectors, would account for 40% of our national emissions, of total emissions. So agriculture and land use is quite a large source. And the other thing to bear in mind, we've a couple of other headwinds we're facing into. And one of the main things is that the global warming potential of methane is rising. And the largest proportion of our agricultural emissions just so happen to be methane. So those methane, because of the changing global warming potential, push up our agricultural emissions. So we have these challenges, and we also have a policy requirement. So the policy requirement is really what are our national emissions and what do we project them to be into the future? How can we mitigate? How much can we mitigate? What are those subcategories that we can mitigate land use emissions by, and what's the cost? So first of all, if you look at our agricultural emissions, the main thing to note for the agricultural emissions is that they, in general, they've been increasing since 2011, mainly due to increase in dairy cow numbers and an increase in fertilizer use over the period following the relaxation of the milk quota. And what you tend to find in agriculture is that it's predominantly made up of methane, not CO2. So the main emission, about 70% of our emissions are methane. The vast majority of those are from enteric fermentation. In other words, cattle and sheep burping methane. The other about 20% of the methane emissions are from manure management, and then the other third or so of our agricultural emissions are nitrous oxide, and they're nitrous oxide associated with fertilizer application, with manure application to land, and also animals urinating and defecating on the field while they're grazing.
Gary, I see liming mentioned on your graph there.
Yeah, and then liming is CO2, and that's a small but probably growing portion of emissions. It's typically only about 3 to 4% of our emissions, but it is projected to increase over the next number of years, as hopefully we'll be applying more lime and getting our soils back into good pH status. The bar here is the reduction target. So we have a 22 to 30% reduction target for agriculture. So that's quite challenging. If you think like the lowest our emissions ever went was in 2011, and the emission reduction we're looking for by 2030 is much greater than that. It's a 22 to, we need to get the emissions down to somewhere between 15.5 and 17.5 million tonnes, and we're running at around about 22, 23 million tonnes at the moment. The other portion of this agriculture and land use piece is the land use piece. So these are our projected land use emissions over the next number of years. And the first thing to note is that we have a forestry that is a mine. So a mine's value means that CO2 is being sucked up, okay, or sequestered. And in general, our forestry land has up to now been a sink of somewhere between 3 and 4 million tonnes of CO2 per year. However, what you'll note in this table is that sink is going down, and in fact becomes a source by 2030. And that's simply because of the age profile of our forestry. So we'll be clear felling forestry at a higher rate than we'll be afforesting. So because of that age profile of our forestry, it is turning into it is going neutral or turning into a small source. The other thing to note is our grasslands. Now, most people, when they think of grassland, they assume that grassland is sequestering carbon. And indeed, our mineral grasslands do sequester carbon. So we have about 4 million hectares of grassland on mineral soils. And in the inventory, they're assumed to be sequestering at about 0.5 ton of CO2 per hectare per year. So that's 0.5 ton times 4 million hectares, that's 2 million tonnes being sequestered. However, we have somewhere between about 350,000 and 420,000 hectares of grassland that's on peat soils. And that's emitting CO2 at a rate of around about, we think, 20 tonnes of CO2 per hectare per year. So it's a source of 9 million tonnes, quite a substantial source. So it means then the net grassland emission the situation is that grassland is actually quite a large source of emissions, and mainly because of these peat soils. And then you have wetlands, which include the cutaway peatland, so the Bordnamona land, for example, and the majority of there's about 2 million tonnes of emissions from those, from about 80,000 hectares of cutaway peat. And then the total is an emission source. And what you can see, because both the forestry sink is disappearing and because we have a large grassland source, we project that our emissions from the LULUCF sector, in the absence of mitigation, will actually go up. Okay, so that's challenging because if you look at these two lines here, so this is our projected emissions, and these two lines here are where the climate bill is saying we need to be by 2030. So agriculture has a 22 to 30% reduction, but LULUCF has a 37 to 58% reduction target. So that's quite a challenging and quite a substantial target, particularly in the context of the fact that our emissions are increasing from the sector in the absence of mitigation. Okay, so this produces a challenge for us, but really, so what can we do with carbon sequestration? How can we reverse this? Well, we can reverse it by a number of things. We can plant more forestry, and forestry sequesters carbon for the lifetime of that forest. So in the case of conifers, It could be 30 to 40 years. And in the case of broadleaves, deciduous trees, typically those forests last for somewhere between 60 and 150 years, depending on the species. And then the other way you can sequester more carbon is to actually deliver more carbon into the soil. Okay, and soil carbon sequestration is actually the one permanent method of sequestering carbon. So you can sequester carbon from decades to centuries to thousands of years in the case of peatland. So if we look at how does carbon sequestration work, well, the plants basically produce photosynthesis. So your grass grows, and typically a grassland will probably take up in photosynthesis somewhere around about 12, maybe 12 to 15 tons of carbon per hectare. And you think to yourself, oh, that's great, then it's sequestering 12 tons. Well, it's not, because the plants have to breathe the same way we do. And those plants, so a certain amount of carbon, maybe about 3 tons of carbon is lost when those plants breathe. And then the microbes in the soil eat carbon, and they also breathe. And then as well, the animals eat some of that carbon, either as silage, or they graze it on pasture. And ultimately, when you look at actually, and then some carbon is leached out of the system, the animal returns some of that carbon in the form of manure or in the form of urine and dung. But if you actually look at how much carbon remains in the soil, it's probably only somewhere around about 1 ton of carbon per hectare per year. So it means you're only adding very small amounts of carbon into what's a large background. And how large are these backgrounds? Well, if you look at sandy soils, a sandy soil, if you compare it to an actual sink, okay, so we talk about carbon sinks. A sandy soil has, because sand can't really hold on to carbon very well, and it has a low surface area ratio. Typically, sandy soils will be able to hold on to maybe about 80 tons of carbon per hectare to a depth of about 30 centimeters. If you go to a clay soil, clay is very good at holding on to carbon. It's got the opposite charge, electrical charge of carbon, so it can bind carbon. So clay soils will typically have carbon contents of maybe 200 to 300 tons of carbon in the top 30 centimeters. And then if you go to a peat soil, peat soils are different. A, they're acidic, but B, they tend to be waterlogged. So there's no decomposition in the soil. So if you've got no decomposition, then the carbon builds up and up. Okay, and again, if you compare it to a sink, you know, your clay, your sandy soil is a small wash hand basin, your clay soil is a bath, and your peat soil is a swimming pool, and they're roughly the differences in the level of how much carbon they can hold on. So you know, you're going from about 80 tons of carbon per hectare for sandy soil, all the way up to 2,000-3,000 tons per hectare in a peat soil. And because the peatland holds on to so much carbon, because it has loads of carbon, and it's anaerobic, so that soil is generally waterlogged. What happens when you drain it? So before you drain it, and it's anaerobic, it doesn't produce too much CO2. It mainly produces methane, the same way as a cow produces methane, because again, in the rumen of the animal, it's anaerobic, so it produces methane instead of producing CO2. And similarly in a peatland, and because it's an anaerobic environment, methane tends to be the main gas that is released. And typically you're talking about 9 tons of CO2 equivalents per hectare per year. However, if you drain that peatland, then that carbon becomes available for microbes to then eat it. So basically what happens is that microbial activity goes up, the number of microbes in the soil increases exponentially. And what happens is that instead of having a small amount of methane being emitted, you now have a very large amount of CO2 being emitted. As the microbes grow, they eat the carbon and then they breathe out CO2 the same way as we do, and basically they are consuming that carbon that has been stored for thousands of years. So if you look at then the actual emission factors that the IPCC have, and you can see that you're talking about quite substantial amounts of CO2, everything from about 7 tons of CO2 per hectare per year, all the way up for, if you have cropland on peat soils, you can be emitting over 34 tons of CO2 per hectare per year. And just to actually put that into context, that's equivalent at 34, that's equivalent to nearly 10 cows per hectare. So it's a very, very substantial amount of CO2 being emitted from both grassland and cropland on drained peat soils. So what we've been looking at in Teagasc is we've been looking to see, can we what happens when we change the water level. So how high do we have to restore the water level in these peat soils? And these are lysimeters, these are cores of peat soils that we've removed from a peatland and that's been used for agriculture in Lullymore, and we brought back to Johnstown Castle, and we've been manipulating the water table height to see how much CO2 is getting released depending on what your water table height is. And what we see is that where you have where you bring the water table all the way back to the surface, you have a low emission of CO2 and a higher emission of methane. But that as you drop that water table, your CO2 emissions double or treble. They go quite substantially, and of course you got a collapse then in methane because you're now going into aerobic respiration. So what we've been looking at is we've been investigating the impact of water table height. The other thing that we're doing now as well is we're putting out our eddy covariance towers. So instead of sampling the soil and seeing how much carbon is in the soil or how much carbon is getting added to the soil, we're directly measuring the amount of CO2 that's being taken up in photosynthesis and the amount that's being released in respiration. And we can essentially do a glorified profit and loss. And so we're going to be doing this. We're doing this now at the moment where we're about a third of the way through putting out all the towers. There'll be 32 in total by the time we finish. And 8 of those towers will be on peatland sites. Some of them on the raised bogs in the center of the country, and then some on blanket bogs out in Sligo, and also on the Dingle Peninsula. And then our raised bog sites are going to be mainly in North Laois and in Offaly. And what we'll be able to do is to see how close are the Irish values relative to the book IPCC values that we're using at the moment. And what we will be able to also do is to then look at the impact of management and see, for example, the relationship between how good a carbon sink or source it is versus things like grass utilization, for example. But so if you then look at so this is a study by Evans et al, and they've been doing these eddy covariance measurements in the UK, and what they've seen is that as you change the water table, as you lower that water table, the emission level of CO2 goes up linearly with changes in water table height. So as you increase, as you bring the water table back up, you linearly decrease the amount of emissions coming from those peatlands. So what it does mean is that you don't necessarily have to bring the water table all the way back to the surface. And of course, what you do see as you re-wet up is you do see this increase in methane occurring. Okay, so then you can actually get and with this they got an empirical, they had a model then of and a good relationship of the impact of water table on net greenhouse gas emissions. So what it meant was then that you can hit a sweet spot in terms of reducing both CO2 emissions, but also not exacerbating methane emissions. And it was somewhere around about at a water table about 20 centimeters below the surface. They found it, and this was in the UK. But the one thing about rewetting is rewetting or raising the water table isn't the same as restoration. So what these are here is these are graphs of rewetted sites versus pristine peatlands, and what you see is that when you rewet, you don't get the same amount, the same vegetation as you'd have on a naturally pristine peatland site, and you also don't have the same hydraulics or the same hydrology in the system. You never quite restore it. And what you find is that in the years following rewetting, you still, the hashed line here is pristine peatland, and these are rewetted sites here. And what you see is that the land cover characteristics are still very different to what you'd expect on pristine peatlands, and also the geochemistry is still somewhat different, and can, depending on the site, take a number of years to recover. The other thing that we've been looking at also is when you actually do drain these sites, how old is the carbon that's getting mobilized, that's getting emitted? And what we see is that in terms of the soil carbon that's being released in a grazed grassland, that carbon is generally quite young, typically probably only about between 0 and 60 years old, but the carbon that gets leached out of the system is very, very old. That carbon that's being leached as dissolved organic carbon can be 1,300, can be 2,000 years old sometimes. So that's carbon that was laid down 2,000 years prior to it. That's now getting mobilized if you drain these sites. So again, the point being is that when these sites are drained, you're losing carbon that has been in that system for thousands of years, really. And ultimately, what we're going to be doing with our eddy covariance sites is then constraining. We're going to be constraining models, but also using satellite data in combination with it, so that we can then create these models, and we can use those models in the inventory and hopefully get a much better value of carbon emissions, and also the impact of changing the water table height, or maybe even just not fertilizing as much on these peatland sites, because again, typically the peatlands would naturally get very low levels of nutrient input. So in fact, actually cutting off some of that nitrogen and phosphorus might stop priming those microbes and stop some of that CO2 loss. And we can then use that to constrain models. And we can also then look at what the impact of future climate change will be on our peatlands and on carbon sequestration into the future. So really, what we'll be doing now into the future is getting a good handle on what's the management impacts on both mineral soils and on peat soils. We need to better understand the underlying processes that are driving both emissions and carbon sequestration. And we're setting up the infrastructure to have a long-term monitoring network around the country in combination with the signpost farms. And in fact, we do have a number of signpost farms where we have peat soils and where we will be rewetting or raising the water table. And really ultimately then what we want to do is then come up with solutions that will reduce emissions and also help preserve the carbon that's in these peat soils. Okay, but ultimately, if we want to get these peat soils, if we want to raise the water table and we want to try and preserve that carbon, ultimately, it's going to mean that the farmer or whoever owns that land is going to have to be actually paid for curating that carbon, and in fact paid the going rate of carbon. So at the moment, carbon on the verification markets is 50 euros a ton. You know, if you're stopping an emission source of 20 tons per hectare, 50 euros a ton, that's, you know, could be potentially €1,000 a hectare, but it is going to have to be something that A, we need to get the proper measurements, but B, it then needs to be resourced. And farmers do need to be paid the market rate for preserving those high levels of carbon, because these peatlands contain roughly about 1 billion tons of carbon in Irish soils, 1 billion tons of CO2, of carbon. And they need to be paid to actually curate that resource, because these are essentially our rainforests, these peatlands, and they need to be preserved. Thank you.
Thank you, Gary, and such a poignant phrase to end on, the peatlands being our rainforests. We have obviously a wide and varied audience here today, and one of the purposes of the series is to educate people and just to introduce these concepts to people. And Gary, if you don't mind, we have just a few questions around the whole sequestration.
Yeah.
If you wouldn't mind, just maybe clarifying, sequestration in a nutshell. Just because I just want to make sure that people are understand the concept.
So again, some people kind of they don't get the concept. So the whole point of carbon sequestration is basically removing CO2 out of the atmosphere and locking it away either in woody biomass or in hedgerows, for example, or in the soil. Okay. And while hedgerows and trees are quite easy to count, so we can actually work out the amount of carbon in a forest quite easily by counting the number of trees. It's much harder to work out the amount of carbon sequestered in soils, because, like I said, in a typical mineral grassland soil, you might only be sequestering a ton of carbon and you're trying to measure that in a background of maybe 200 or 300 tons of carbon. So it'd be like me saying to you that I give you a water level in a swimming pool, and the only way for you to work out how much water is being added into it is by looking at the change in the height of the water in the swimming pool. So that's the sort of challenge that we're facing. We're measuring a very small input in a very large background.
Just in relation to the inventories and the measurements, how in practice are those areas of peatlands calculated? The different areas to actually come up with those figures. So
at the moment, what happens is we use a book value. So we're using what's called a tier 1 emission factor, which is a generic IPCC value. And until we have national data, we're obliged to use that tier 1 emission.
The actual areas, how are they attributed or to? Okay,
so the areas, and again, this is actually a piece that's actually has been relatively uncertain up to now, but I know Stuart Green in Teagasc and John Connolly in DCU have been doing a lot of work to actually get a proper handle on how much of this peatland that is in agricultural production, get a handle on exactly how much there is in the inventory. I think it's assumed it's about 350,000 hectares, but the truth is, Mark, we up till recently we actually didn't know. So
it's kind of remote sensing type.
So it was remote, yeah, exactly. Yeah. It's done using remote sensing, but I think we're getting a better handle on that now.
Okay, Gary, you've been working in this area for a long time now, and obviously there's been major changes or disruption to fertilizer supply chains, and over the last number of weeks and months. And I think a lot of people are now looking at the agricultural system that we operate here in Ireland, and maybe our dependency on external sources of inputs, we'll say. I mean, where do you see us heading over the next number of years around production systems?
Yeah, well, I suppose it's opportune at the moment, because we have always said that for us the easiest way to get at our agricultural emissions is to first sort out our nitrogen and our nitrous oxide emissions, and really I suppose the two main ways of doing that are to put legumes in. So you put in a legume, you're essentially getting free nitrogen. Because if you have about 30% of clover in your sward, that's going to be fixing somewhere between about 90 and say 120 tons of nitrogen per hectare. And then the other thing is to get your pH right, because like 2/3 of our soils are at suboptimal pH. And again, if you think about it, if you bring soil pH back from say 5.5 back to say 6.3, 6.4, you're going to be releasing about 70 kilos of nitrogen per hectare. Again, so I suppose the increase in the price of fertilizer has come at a bad time in some respects, but also a good time in that it's we do have these targets to reach, so it's an opportune time now for people to think much more carefully about particularly the use of nitrogen fertilizer, utilizing their slurry or their manures as best they can to optimize the nitrogen fertilizer replacement value of it, and then also looking at things like either multi-species swards or grass clover to fix more nitrogen into the system, and to really, I suppose, wean ourselves off mineral fertilizer as much as we can.
Okay, I see a huge amount of questions coming through here, so we better get stuck into them. And thanks everybody for your interest, and do keep the questions coming using the Q&A tab at the bottom of the screen. Pat.
Yeah, I think a general theme coming through from the questions is just a word of thanks for a really enlightening talk. I think people are really getting what you're saying. A question here from beyond payment, farmers will need major tech support in a very complex area. But there's, I suppose, the question that's coming there is, will this land that we're talking about be sterilized, or is there still a role in agriculture for the land that you're talking about?
Yeah, so I think that the point is, Pat, it's not a one size fits all. It's not that we're going to be flooding the whole of the center of the country and turn it into a big lake or anything. So depending on the context, different farms and different might utilize different methodologies. Some of them might simply stop applying as much, putting as much nutrient inputs onto the land, and that might go some of the way to reducing those emissions from the peat soils. Or you can seasonally re-wet or raise the water table up. Or as I showed in one of the graphs, you don't have to bring that water table all the way back to the surface, so you could still have it. You can still get quite a bit of the benefit.
At the moment, Gary, there's no market there for that, for
no,
carbon.
This
is the challenge, isn't it?
Yeah. So the DG Klima, and I know the Department of Agriculture are talking about a carbon farming scheme. I think sometime next year they're talking about that. But yeah, until we have a mechanism that will pay the farmer for reducing that emission or improving the amount of sequestration, until you have a price for carbon, then there is no mechanism, there is no policy lever at the moment. So we know, for example, the Department of Agriculture have a target of about 80,000 hectares that they want re-wetted, but at the moment that there's no impetus, there's no lever to actually get that happening.
Yeah, and I think that there's a question here that follows on, and I suppose a little bit of impatience among some people. What's most important, accurate measurement or behavioral change to move ahead?
I would say both.
Yeah.
I would say both. The problem is, if we don't have an accurate measurement, then the market will have no integrity. Because if I say to a farmer in year one that by rewetting your peatland, you're cutting off 20 tons of carbon, and I'm paying him €50 a ton, and then I turn around next year and I say, oh, actually, it's only 10 tons. When we get a better estimate, for example. So you do need the proper measurements in order to have market integrity. I think the other thing that you have to be very careful about is that you don't double account. So depending on who is going to purchase those carbon credits, who's going to pay the money, whether it's the exchequer or whether it's the private market, is going to need a lot of thinking about. And because if it is the private market, then you sell the credits along with they're buying those credits off you, and that has the potential then for any emissions reductions to leave the agriculture sector, or even to leave Ireland if it's a company that's not Irish. Mm-hmm. So you have to be very, very careful in setting up the market so that you don't double account, but also that you're giving a fair price for carbon, and that the market has integrity, mm-hmm. that we know the numbers are right.
Okay. And I suppose if the payment to farmers comes in the form of more of an agri-environmental scheme than a specific payment, it then would be possible to maintain the credits within the agriculture.
It would, but again, it's going to really depend on what, you're not going to get a functioning market, or you're not going to get behavioral change unless you offer a fair price.
Okay.
Yeah.
Just a question here, getting back to, there's a few questions in relation to mineral soils. Could Gary comment on the optimum stocking intensity on grassland, intensive dairy grazing platform versus extensive dry stock in terms of their ability to sequester carbon, and also maybe a comment on ploughing versus min-till?
Yeah. So okay. So the grazing one first. So there is certainly there is evidence out there, and I showed it in one of the graphs that a grazed pasture sequesters more than a silage cut pasture, and that's because when you're grazing grass, you get more root turnover and roots, so you actually get a bit more sequestration. However, as the grazing intensity goes up, say past about 1.5 livestock units per hectare, if you have overgrazing, then of course you're going to have compaction and poaching and things that will then retard the amount of carbon being sequestered. So it has a kind of a hyperbolic relationship, but the rule of thumb is that the optimal stocking rate, grazing stocking rate, is somewhere between 1.5 livestock units per hectare to optimize that amount of sequestration. And
on the tillage and min-till side?
And then on tillage and min-till, so again, what we have found in both Oak Park and Knockbeg is that min-till, certainly you've got higher numbers of earthworms. The soil tends to have better structure. However, the amount of carbon in a min-till soil isn't that much higher than in a ploughed soil. It simply redistributes it at different depths. So in a min-till system, you'll have higher carbon in the topsoil, in the top, say, 10, 15 centimeters. But actually, when you measure all the way down through the soil, through the plough layer profile, we found not a huge amount of difference. Where you do see min-till working is in say in soils in the United States, for example, because they've got a low level of turning areas. But also there seems to be an additional, because you're improving soil structure, you seem to be able to retain soil moisture better. So some of it's actually a moisture impact and moisture effect, I think.
Okay, sorry, go ahead.
A few questions coming in. Just I suppose a degree of frustration coming across from some people about what they can do on their farms today to support sequestration in terms of best practice. So
again, for mineral soils, we would say put a legume in, or move to species mixtures, because then you get you've got different rooting depths, and the evidence tends to be that legumes and species mixtures sequester more than lowly and monocultures. Optimally manage your soil nutrient status. So if you're optimizing the amount of photosynthesis, i.e. optimizing the amount of grass being grown, you'll also help optimize the amount of carbon being fixed into the system. Yeah. And then part of that has got to be then, of course, getting your soil pH right.
What about tree planting?
Or tree planting, so agroforestry, for example, you could go to agroforestry, or you could plant hectare trees, or sometimes it could even be a riparian buffer strip by a waterway, for example. So it doesn't necessarily have to be forestry. It could be tree features, but also what we're finding as well, allowing your hedgerows to grow, out a meter and up a meter, instead of having a tight back and sides on it, is much better from a carbon point of view.
And obviously there's biodiversity benefits there that we haven't really discussed at all. I see a few people have mentioned those points, that, you know, this rewetting will also have other benefits to it as
yes,
well.
And absolutely, if you raise the water table and if you move back towards more of a peatland type situation, then of course there's huge biodiversity co-benefits.
There's a question there, a fairly specific one in relation to interdrumland peats. Is there possibilities in terms of rewetting where those have been drained?
Yeah, and again, it's going to be different depending on where you are. So, you know, some of the challenges on our raised bogs, for example, is going to be if you're rewetting farm A, how do you stop farm B from flooding? And then on some of the blanket bogs, there might be a challenge of actually raising that water table up, in fact. So again, different situations and different peat types are going to require different sets of measures.
The question there is to how ultimately are we going to measure the impact of various practice changes on the soil carbon? Is it through soil sampling, or are there other methodologies that we will need to bring to bear?
So ultimately, for the mineral soils, it'll be through soil sampling. For the peatlands, it'll be monitoring those emissions, and once we have a good handle on what they are emitting and what the impact of rewetting is, then it'll simply be you know, a scheme of raising the water table, or, you know, changing how that land is managed in some way, shape or form.
Gary, there's a Department of announced incentives for, I suppose, tillage farmers to expand their areas cropped this year. Yeah. Potentially some grasslands being ploughed to expand this area. Is there a carbon release there, or what happens?
Yeah, so again, it depends. It depends. Like if you look traditionally, Mark, a lot of our tillage land is on quite sandy soils because they're nice and they're trafficable, and it just so happens that those soils actually don't hold very much carbon. So when we look at a lot of those, say, brown earths, for example, whether they've got cropland or grassland or forestry on it, it's not those very sandy soils aren't very responsive to even changes in land use. The carbon content only probably changes by about 10 tons per hectare or so. Whereas if you were to plough up grassland on, say, a podsol or a glaze sol, or, you know, something like that, you'd be doing, that's something I wouldn't recommend. You'd be doing a lot more damage there, and releasing a lot more. So what we see is that, again, the higher the clay content, the more carbon you can hold in, and the more responsive those soils are to different land use types. So again, the heavy, if it's a silty, clay, loamy soil, you know, you wouldn't necessarily recommend ploughing that up. But if it's a sandy soil that's normal, you know, that's and the soils that are historically in tillage, there's probably not as huge an impact on those soils.
So that's useful.
Sorry, Gary, I think two things to me came from, I suppose, the early part of your talk. One is that you have put in place quite a bit of research over the last while around this issue, and around the impact of carbon sequestration. The other, I suppose, is how big this is in the whole greenhouse gas picture for Ireland. Yeah. In that context, while we're starting to make progress in this area, are we doing enough? Or is there a scope for increasing the focus of research and, I suppose, of knowledge transfer, which will follow it?
Yeah, well, I suppose if you look at it in a kind of, if you look at it in its broadest context, the two things that can actually make a difference is the peat soils, because they are our big emission source, but also forestry, because forestry is our big sequesterer. And the problem is that we're not we're not re-wetting any of these peat soils yet, and our forestry planting rates are through the floor. And really, if we want to get movement on meeting the targets that we have, both of those are going to have to be done. In the short term, for our 2030 targets, the re-wetting piece, or the management of the forestry stock we have in place at the moment, is going to probably do the heavy lifting. But in the longer term, and I'm talking about out to 2050 now, and we're always talking about net carbon neutrality or net climate neutrality by 2050. It's getting trees into the ground is going to be the big one. So getting the afforestation rates up. Like I said, we've been averaging about 2,500 to 3,000 hectares of planting over the last probably 3 to 4 years. We need to be up at about 8,000 hectares. And historically, during the reason, of course, that in fact our clear felling is outstripping our planting rates is because we planted a huge amount of forestry. Around about the early 1990s up to about 2000. We were regularly planting 16,000 hectares per annum back then. And
there was also inappropriate planting, I suppose, at that time.
There was a lot
as well,
of, yes,
wasn't there,
absolutely.
Peat soils and
there was a lot of inappropriate planting, absolutely, and in fact, a lot of inappropriate planting on peat soils that will be deforested and won't be replanted.
And will those lands then be suitable for these types of measures that we're talking about today? Well,
we don't know. The problem is that even if you deforest and then put it back into peatland, it will still be an emission source for a period of time. And of course, you're actually not replacing the trees that you had in there. So we're probably going to have to need some sort of a derogation or something for that, because that's land you really, from an environmental point of view, don't want to reforest, but at the same time then it's counted as deforestation, so it impacts then on our land use inventory. So yeah, something probably needs to be sorted out with that.
So a lot of work to be done there by the sounds of it. Pat, I think we've time for one final question.
Yeah, I suppose there's 2 questions around, I suppose, the area of water. Is there any work being done on polluticulture, raising water tables and planting water loving trees and plants?
I do know that with the 2, so there's 2 EIPs currently out there looking at re-wetting. There's one called Farm Peat and one called Farm Carbon. And then I know some of the Farm Carbon farms are thinking about looking at polluticulture. So it is one we'll probably come back and revisit. Now, we did a bit of work probably about a decade ago on things like breed canary grass and stuff like that. But again, it's not something we've done for quite a period of time. But certainly there are opportunities there for alternative crops. Yeah, absolutely.
And I suppose a left field one, which might lead to a different talk. What contribution does the marine environment make to sequestration potential for Ireland?
In fact, the largest amount of carbon is actually stored in our oceans. Our oceans store, I think it's something like 80 billion tons of carbon. So they are the single largest sink, but that's not something I cover. But there is research done on it, on the amount of carbon.
Somebody else on another day.
We'll have to have somebody from the Marine Institute, I think, to talk to that one. Look, I think we're going to have to leave it there. We're just over the 10:30. Gary, thank you so much for a really excellent presentation. Huge compliments coming into our Q&A, and thank you everybody for excellent questions today. And thanks to all our audience today, especially we have also quite a few people dialing in from overseas, given the importance of this topic. So it's nice to see that level of interest. Gary, thank you again. Pat, thanks for helping the questions today. And I want to say thank you to Yvonne and Yvonne Maher for assisting with the technical side today, Andy Boland. So next week, we'll see you again at 9:30, and we'll be advertising the new schedule for the coming few weeks during the week next week. So with that, enjoy the weekend. Hopefully the fine weather will continue, and we get out to enjoy this lovely country of ours. So until then, we'll talk to you next week. Bye-bye.
Bye.